Hey guys, Mrs. Dan's here. So I'm going to do this review. Remember, you have a test on Monday. Watch this video as many times as necessary, and remember there's extra help Monday morning. So I'll go through each question and hopefully it's helpful. So what is the solution set of the absolute value of x plus 1 that equals 9. So remember, to be a solution means that there's some value of x that makes this true. So since it's multiple choice, you could just substitute some things in, like does -5 work in place of x? On something on number 2, really what they're saying is that there's two different answers. Maybe it's -4 and 5. And number 3, again, they're saying two different answers. And number 4, they're just saying that there's just one answer. So something that you should remember is that lots of absolute value equations have two answers. So that's kind of like a hint that maybe it's either choice 2 or 3. Remember, what's here in parentheses, in absolute value symbols, after I take the absolute value of it, it should turn out to be 9, which means the stuff in here could be a 9, right? If 2x plus 1 equals 9, then when I take the absolute value of it, of course, it will be 9 as well. So if you wanted to just solve this, you would definitely get one answer. So I get that x is 4. So it's looking like maybe it's choice 3, maybe it's just choice 4, like maybe -5 doesn't work. How about if we just test out that -5? Is the absolute value of 2 times -5 plus 1 equal to 9? Well, this would be the absolute value of -10 plus 1, which is the absolute value of -9, and guess what the absolute value of -9 is? So really, choice 3 does work. Most absolute value equations have two answers. Number 2, the range. Remember, range are the y values. That's important. So we're looking for y values, which really means I can cross off choice 1 because these are saying x values. I could actually cross off choice 3 because they're only talking about x values. This is an absolute value function. So I like to think about what the graph looks like. You could put it actually into your calculator and take a look at that. In the y equals button, I could put the absolute value of x minus 3. Remember, my calculator is not as updated as yours. So mine says ABS. Yours will actually have the absolute value symbols. And then plus 2 on the outside. And if you want to just look at the graph, I suggest don't hit graph. Hit the zoom button. And then hit number 6, which is standard. So it gives you a standard graph. And take a look at that. It's a V that opens up. It makes sense that this is where it is because this -3 tells me it shifts to the right 3. And it did. And the plus 2 outside means it shifts up 2. So it makes sense that this is where the V is. So the y's are all greater than 2. So it really is choice 2. All y values greater than 2, because right here was the 2. This graph, this is a right-left shift. It shifts to the right. No. Shifts to the left. 2. Remember, it just shifts the opposite way of what we would think. So I'm looking for something that shifts left 2. I'm actually not looking for it. They graphed it for us already. Maybe I should read. So the graph is shown below. Yep, there it is. It shifted to the left 2. Which graph represents y equals negative the absolute value of x plus 2? This means it has to open down. So I could eliminate some choices. Eliminate choice 1 and choice 3. it's going to open down, but it's going to be the reflection of the graph they gave us. So it still has to be in this same location, just opening downward. So that's why it's choice 4. So which transformation of y equals f of x moves the graph 7 units to the left, which would be a plus 7 in parentheses, and 3 units down, which would be a minus 3 outside parentheses. When they use this notation, they're talking about some function, some general function that we really don't know what it looks like. But our shifts work the same for every single function we ever do. So inside parentheses plus 7, outside parentheses minus 3 is choice 1. Number 5, Dominic graphs the equation. Again, this is a little more specific. I see absolute value symbols, so I know it's a V-like shape. And A is a little general. A is some number. Remember, this number in front of your absolute value symbols changes the width of the V. Also, if it's positive, it opens up, or if it's negative, it opens down. Here they're saying it's positive, so I know it's opening up. So now if Gina multiplies A, this A in front of the absolute value symbols, by -3, then the new graph will become, well, first of all, I know it's going to open downward. So it's not choice 2, and it's not choice 4. And remember, when you multiply by a 3, it like makes the graph steeper. If each side of a V becomes steeper, it actually becomes more narrow. The higher the number, the more narrow it is. Fractions make it wide. So it's choice 1. Number 6, the maximum point on a graph of the equation y equals f of x, again, some general function, but they're telling me the maximum point is at 2, -3. That's the maximum point, which means all other points are someplace underneath it, whatever the graph looks like. The maximum point, though, is the only one I'm worried about, is at 2, -3. So what's the maximum point on the graph of the equation of y equals f of x minus 4? So these two things are related. Since they both have f, they're talking about like the same function, but this minus 4 inside is telling me shift it to the right 4. So how about I take that maximum point and go to the right 1, 2, 3, 4 units. If I go to the right 4 units, it's really now at 6, -3, choice 4. Which graph does not represent a function? Functions are never allowed to have 2 points one above each other. So it's got to be choice 1 that's not a function. All of the rest are functions. They meet the criteria of every input can only have one output. Number 8, which rule describes the relationship between x and y in the accompanying table? So something that stands out to me is that those match up, which means this is a vertex. Which means it shifts, doesn't shift right or left. So nothing in the parentheses, but it does shift down 3, so I need a -3 outside of the parentheses. It's got to be choice 3. But if you're not sure, you're going to take your graphing calculator and you're going to enter this into your y equals. We will do the absolute value of x. Remember math. Over to num. Number 1 is absolute value. I need to do the absolute value of x. I have to close my parentheses. Yours will be inside absolute value symbols. And that -3 has to be outside your absolute value symbols. I'm going to look at the table, not the graph. Remember, you hit second function, and the graph button gets you to the table. And let's see if this table matches. So the -1, -2 is here on my calculator. 0, -3, 1, -2, 2, -1, it matches. I am confident that this is my answer. Number 9, data collected during an experiment are shown in the accompanying graph. What is the range of this set of data? Remember, range are the y's. So I can cross off choice 2 and choice 4. Range are the y's. So from here to here, right? It's along the y-axis is what I'm looking for. My range goes from 0 to 100. It's got to be choice 3. What is the domain? The domain are the x's. So get rid of choice 1 and choice 3. The x's start here and go to here. So about 2.5 to 9.5. I guess it's choice 2. So just don't confuse the ranges with the domain. Given function p of x as defined below. So this is a piecewise function. This first piece, the y-intercept is at 1. The slope is 2 over 1. So I'll start at 1 and go up 2 over 1. I go in the other direction. But now I'm going to erase some pieces. It exists for all x's that are less than or equal to -2. Here's -2, and this way are the things less than it. So I'm going to connect these. If I had my index cards, I wouldn't have drawn this line. I would have covered things with my index cards. So I'm erasing everything that doesn't belong. The next piece, the y-intercept is -7. The slope is -2 over 1. So I'll start at -7, go down 2 over 1, and in the other direction. I can never have points one above itself, so I'm sure all of these are going to be erased. I'm sure, because I can't have points one above itself. But let's check it out. It says that x has to be greater than -2. Here's -2, greater than is that way. So yes, I am going to erase these. Find the value of p of -2. It means go to where x is -2 and look at the y value. The y value would be a -3. So we would say that p of -2 equals -3. We graphed it already. Function p can be written as an absolute value function instead of a piecewise function. Oh yeah, because it is this symmetrical V-like shape. Write an absolute value function and represent the graph. So I need you to remember that the format of absolute value functions is some number in front of the absolute value symbols, x plus some number because that's a shift right or left, plus some number outside because that's a shift up or down. This is Vertex Form when I put it in this format. So since it's opening downward, I need a negative. Its slope is 2 over 1, so it's actually a -2. It shifted from the origin, it shifted to the left 2. So a +2 inside the absolute value symbols, and it shifted down 3, -3 outside the absolute value symbols. And what is the domain and range of the function? So the domain, remember, is from left to right. Since it's an arrow, it's going forever to the left and an arrow forever to the right, so it's all real numbers. The range, though, is not all real numbers. because the range doesn't ever go above -3. It's everything below -3. So it's all y's less than or equal to -3. Or if you like interval notation, it goes from -infinity to -3. On a set of axes, graph and label the equations. So I'm going to graph two equations. It would have been nice if maybe they called this f of x and this one g of x. I like it when they name it two different things so that I could label each thing. So I'm going to change that. So f of x equals the absolute value of x. It doesn't shift right or left. It starts at the origin. And the number in front of the absolute value is 1, so it goes up 1 over 1. Oh yeah, that's right. This is called the parent function. Now, when we do absolute value graphs, we usually draw arrows and say it goes forever in both directions. We like to say that the domain is all real numbers, but there's a giant but in this question. They want me to graph it only from -3 to +3. So really, I have to erase some things. They want me to stop at -3 and +3. They don't want this arrow. So that's the graph of the function. So if they give you a certain interval to graph it over, you have to follow that interval. And I called this f of x. And then the other one I called g of x. It doesn't have a shift. It just stays at the origin, but it's more narrow because it goes up 3 over 1. And that one should also get graphed from -3 to +3. So there's actually a problem with this graph because the graph paper is not big enough, but I'm just going to make it work. So I've had this on pause since the bell rang and I had to teach classes. So I just want to pick up because I'm not sure what I left off saying. So I named this first function f of x and the second one g of x instead of them both being y. And we said that this first function that I called f of x is actually the parent absolute value function. And the thing that we had to be careful about when graphing this was that they only wanted me to graph it over the interval from -3 to 3. So instead of putting arrows at the ends, I actually put closed circles at -3 and +3. And when I graph g of x, which I haven't labeled yet, there's g of x. I said, unfortunately, this graph paper really wasn't big enough to go from -3 to 3, so I had to extend it. On a test, of course, the graph paper would be sufficient for you to do whatever problem is on your test. It asks us to explain how changing the coefficient of the absolute value function from 1 to 3, because in f of x it's a 1, but while in g of x it's a 3, how does that affect the graph? It made the V-like shape more narrow. I just want to continue with this question even though it doesn't ask. If they asked me for the domain of this function, the domain would have to be from -3 to 3 because that's all they told me to graph it over. While the range is all y values greater than or equal to 0 for both of these functions since their minimum point is at 0, 0. Number 12 we did in class. I'll do it again. I told you in class that this really isn't a piecewise function. It actually isn't even a continuous function, like I couldn't attach the points because we're talking about the number of pencils. So if you buy 0 to 9 pencils, you're spending $1.75 per pencil. So for one pencil, you're spending $1.75, and I had told you that you could enter this into your calculator. So we'll do that one more time. Also, just in case you need some more practice, so you go to your y equals button. I'm going to clear out what I have in there, and I enter the function. The function is 1.75x. And you can look at your table of values by doing second function graph, and I can then just copy the information. So 2 pencils will cost me $3.50. Um, 3 pencils, $5.25. 4, 5. We're only going up to 9 pencils because once you purchase 10 pencils, it's a different rate. Just scroll my calculator down a bit. While I'm here, I might as well just stay on my graphing calculator for a moment and graph this, where if you buy 10 or more pencils, you're only paying $1.25 a pencil. So this table, remember, doesn't start at 1. I have to start at 10 because I can only pay that $1.25 if I'm purchasing enough pencils. So if I go into my y equals, clear this out, and do $1.25 instead for each pencil x, and then look at the table and scroll to, so 10 pencils is $12.50, 11 pencils $13.75. I'm just going to write down up to 13. It does go forever, I guess, until the store runs out of pencils. And like I said, this is considered a discrete function. So I'm going to plot, I'm going to estimate where $1.75 is. And I'm plotting the first table that I wrote down and just estimating where these points are. So I plotted all the points from my first table. I'm not going to connect them because I can't buy pieces of pencils. The next one, when I plot, you see that it starts down lower again. And again, I'm not going to connect these. And these points, like I said, they actually continue because I could buy more than 13 pencils. But this is the best I could do with the graph. It's really not considered a piecewise. Like I said, I call it a discrete function because I don't connect the points. If I connected them, it would be like continuous. But if a customer brings 8 pencils to the cashier and the cashier suggests that the total cost to purchase 10 pencils would be less expensive, and we have to state whether the cashier is correct or incorrect and justify our answer. So I actually like looking at the graph and I'm going to look at 8 pencils. And for 8 pencils, I can see it's going to cost $14. Then I look at 10 pencils, and for 10 pencils, it's going to cost $12.50. So guess what? The cashier is right, and that's what we have to write. Since it says justify your answer, I should write a little bit more, and I will say 8 pencils costs $14, and 10 pencils costs $12.50, and that's justification. Now this one, I am going to make some assumptions here. It's probably the way most people would read it, but we're talking about this plumber who's going to charge $50 for a house call, and it includes the first hour of work. So that very first sentence, really, I think there is no controversy. I am going to pay $50 for him to come to my house and stay for an hour. But then, if I need him to stay longer, he's going to charge $30 per hour. And I guess that's the part that there's a bit of, I don't know, debate over what are they talking about. Is it a step function or is it gradually increasing? I'm going to do it as a gradual increase just because I am. So I'm going to label my x-axis with the number of hours. Since it's the number of hours, I really want to go just by 1. And my y-axis will be the cost. And the cheapest it's going to be is 50, and then it's going to continue to increase by $30. So I think if I go by tens, I should be able to fit enough of the information. And like I said, this first piece is $50 for a house call, which includes the first hour. There's no controversy at all. I'm going to pay $50 for any part of an hour up to an hour. But then if he stays longer, he's going to charge $30 an hour. And this is why I said there's some controversy. Some people say, okay, well, let's go up 30 over 1 because now he's going to charge $30. And some people think it should be a step function. I think I should put a horizontal line and then go up another 30 in horizontal line. Maybe that's true. I wish it was a little more clear in the wording. I wish it said $30 an hour or any part of an hour, but it doesn't say that. So I am going to do it as a gradual increase, and it keeps on going up $30 per hour. On your test, it's all stated very clearly, so you don't have to guess, what are they talking about. There won't be any confusion on your test. And I'm just going to put an arrow and say this is just going to continue because we don't know how many hours he's going to stay for. So it asks us to graph a piecewise linear function, and I did. Now it asks us to write that function, so there are 2 pieces to what I wrote. The first one is a horizontal line at 50, and it exists from 0 to 1. I'm including that 1 hour in the 50 because it does say he charges $50 and it includes the first hour of work. So after the 1 hour is when it increases, when we pay $30 per hour. But I'm going to do this as a shift, so I need parentheses. It shifts to the right 1 and up 50, right, if I use this point as a shifting point. So it's going to be a minus 1 and then a plus 50. And that's how we can write our second piece. Instead of backing it up to the y-axis, I could do it as shifts. I could have backed it up to the y-axis and said it would hit the y-axis at 20. But take a look. If I were to distribute this and combine like terms, I do get the 20 anyway. Okay, so you can write it either as 30x plus 20 or as the 30 times x minus 1 plus 50. Either one works. You only write it one way, you don't write it both ways. I'm going to stick with my shifting way, so I will erase this information, just so when you look back it doesn't get confusing. I just wanted to show you that it really meant the same thing. This exists for all x's greater than 1. And then they ask what are some restrictions on the domain. And the reason why they ask that is because this really doesn't go on forever. It really doesn't go into the negatives. So you can't have negative hours, therefore it doesn't go into the negatives. This job will eventually stop, so it really isn't going off to positive infinity. So those are restrictions that they're talking about. Number 14, it takes Ariel 60 minutes to reach the hiking team's campsite. And we could see that from the beginning of her trip to the end of her trip, 60 minutes has passed. And she's following a trail that we can see in the graph. What is the change in elevation between her starting point, which is here, and the campsite, which is here? The change in elevation went from 5 to 25. So the change is 20 feet. And we have to write a piecewise linear function for this. So there's 1, 2, 3, 4, 5, 6 pieces to this. First piece is horizontal at 5, and it exists from 0 to 10. The second piece has a slope that's going up 5 over 10. Up 5 over 10 is really 1/2. And I feel like doing this as a shift. I'll use this point as my shifting point, since it's part of that line segment. So it's shifted to the right 10 and up 5. And it exists from 10 to 20. I already included the 10 in the first piece, so I'll put a less than. In this one, I'll put a less than or equal to. Next piece is horizontal at 10. It exists from 20 to 30. I have to put a less than on the 20 since I included it in the other piece. The next one is going down 5 to the right 10. So that's a negative 1/2 slope. I'm going to do it as a shift. I'm going to use this point. Remember, there are many points you can use, so you have to look and see which one I'm using. With that point, it shifts to the right 30 and up 10. It exists from 30 to 40. The next piece is a very steep line. It goes up 5, 10, 15, 20. Goes up 20 over 10. 20 over 10 is the same thing as 2. So the slope is 2. Again, I'm going to use a shift. I will use this point as my shifting point. Shifts to the right 40 and up 5. Exists from 40 to 50. And the last piece is horizontal at 25, and it exists from 50 to 60. So I included my starting point because I was there, so I feel like it's a closed circle. So that's why I made it equal at 0. And then remember, if it equals in one piece, it can't equal in the other. So you have to be careful. One has to be less than or equal to, while the following line segment I made it less than. What elevation is Ariel at when she hiked 32 minutes? So I like to look at my graph for my answer, but it really is difficult for me to see what that exact point is. So I can see on the graph that it's in the 1, 2, 3, 4th piece. So I'm going to use my 1, 2, 3, 4th piece, the negative 1/2 times x minus 30 plus 10. I'm going to use that equation and substitute in 32 for x because x represents minutes. If I follow the order of operations, I do what's in the parentheses first, and then I multiply this. Oops, I'm thinking ahead. And I wind up getting 9 as my answer. And when I look at the graph, 9 seems like it could make sense. 9, what are these units? Feet. And now it asks how many minutes into the hike is she at an elevation of 15 feet. I could find 15 feet easily, but again, on the graph, I'm unsure. Somewhere between 40 and 50. It's in the 1, 2, 3, 4, 5th piece. 1, 2, 3, 4, 5th piece. So I'll use 2 times x minus 40 plus 5. But remember, here they're telling me the elevation. They're telling me the y value. So 15 has to equal this 2 times x minus 40 plus 5. I'm trying to find how many minutes. I'm trying to find the x. So when I distribute and combine like terms, finally, if I divide by 2, I get that x is 45. And that's minutes. And I did say before it was between 40 and 50, so 45 seems to make sense. Remember, what you do algebraically has to make sense with what you have graphically. Number 15. We can't graph something like this. Well, I guess we can. I guess I shouldn't use the word can't. We choose to put our equations in vertex form to help us graph more efficiently. So when it says rewrite in vertex form, this is where we're supposed to undistribute. And I'm going to show you how to use your calculator to test to make sure you did everything correct. So vertex form, once again, is some number outside your absolute value signs, something that shows a right-left shift, and something that shows an up-down shift. This is the form I'm trying to get it into. So I will undistribute this coefficient of 2. Since I'm undistributing, I have to think about when I distribute, how do I get it back to saying 2x minus 4? Well, this first term must be an x, and this second term must be a minus 2, because now if I distribute, it would say 2x minus 4. Next, we take the absolute value of this coefficient of the number that I undistributed. So f of x equals absolute value of 2 is 2, so it could come outside of the absolute value symbols. And there we go, vertex form. Since it's in vertex form, I can state the vertex. This is a shift to the right, so it's a positive 2. This is a shift down, so it's negative 2. I can graph it now just using that vertex of 2, -2, and knowing that it's steep. It's going to go up 2 over 1 on each side of the V. And I had told you I wanted to use our graphing calculator to make sure this is right. So if I go to y equals, if I enter the original equation, absolute value of 2x minus 4, and then minus 2. Make sure that minus 2 is on the outside of your absolute value symbols. In this same screen, I'm going to put what I think my vertex form is, which is 2 times the absolute value of x minus 2, and then minus 2 on the outside. So if my vertex form is right, when I look at my table of values, it should be identical for each of these functions, because really it's the same function. It's not two different functions. It's the same exact function, just rewritten a slightly different way. So if we go look at our table, I can see that it is identical. Okay, so that's so important that you guys know how to check yourselves. And here's another check. I graphed this using the vertex and how narrow the graph is. You could just plot these points. Take a look at these points. Here is the symmetry in the graph. So since I found symmetry on my table, I could say the vertex is at 2, -2. Good thing that's what I did. And I could plot -1, 4. And there it is on my graph. And 0, 2. And 1, 0. All of these points are on my graph. Please don't just graph something and hope you're right. Make sure you really are right. Next, I want to talk about shifts. So this, or I should call it transformations. These transformations happen to be shifts, but we could do a transformation that makes things more narrow or wide or upside down and things like that. This definitely is a shift to the right. Shift to the left. 3 units. When it's outside the parentheses, it's a shift up 3 units. This is a shift to the right. And finally, we have a shift down. Inside the parentheses are your right-left shifts. They seem to shift the opposite way of what you would expect according to the sign. Outside the parentheses are your up-down shifts, and they shift the way that the sign says. And now some review of past units. Almost done. So the fifth term in an arithmetic sequence. Stop right there. I had told you in class that I need you guys to start writing things down when you learn some information. The fifth term. Oh, let's make some marks for ourselves. First term, second, third, fourth, fifth. The fifth term is 40. Okay, this helps me out greatly already, just seeing it like this. It's reminding me that I have to keep on adding on some kind of number to get to 40. They also tell me the 10th term, 6, 7, 8, 9, 10th term is 60. I can now figure out what must have gotten added on in order for me to get to 60. From 40 to 60, we're adding on an additional 20, but that 20 got added on 1, 2, 3, 4, 5 after adding something on 5 times. That means I must have added on a 4, because 4 times 5 is 20. So this must be a 44, 48, 52, 56, and if I add on 4 more, I do get to the 60. So the common difference is 4. I just figured out I add on 4 each time. So they're asking us to write an equation for the nth term of the sequence. I have showed you that it's similar to linear equations. It's the same format. Arithmetic sequences always turn out to be linear. So it's similar to y equals mx plus b, except since it's a sequence, we like to use a sub n. And the rate of change is really your common difference. And we like to add on the 0 term. And that's the thing that maybe throws some people off, because this is the first term. There isn't a 0 term here. So I can back it up to that non-existent term. I can follow the pattern and find what that number is. On your Regents exam, they actually give you a formula that I notice some people have been using that says the arithmetic sequence is equal to the first term plus n minus 1 times the common difference. And I could rearrange this formula in different ways, but honestly, I use this because it just makes sense to me. I can now go find the term that comes before the 5th term. It must be a 36. And I can find what comes before that. It must be a 32. And I can find what comes before that. It must be a 28. And I can find before that, which is a 24. Remember, I said if I'm going to use what I like to write, I need the 0 term. So why don't I go back one more to 20? So my equation, or my explicit formula, is going to be a sub n equals the common difference times n plus the 0 term. This would generate my equation I have there. And if you don't believe me, check it out on your calculator. If we go to our y equals and enter in 4x plus 20 and go look at our table of values, remember that a sequence really starts with the first term. So I feel like looking here. The first term is 24. The second term is 28. Remember, they gave me the 5th term. So I know the 5th term has to be 40. It says right here that the 5th term is 40. They told me the 10th term. So let's go see. The 10th term is 60. My equation is generating the sequence that they were speaking about. I know I'm right. So double check yourself, guys. Use the calculator as a tool. Write the first 4 terms in a sequence. I do have them up above. I'll just write them again here. On number 17, they're giving us a formula. I actually know that that's the common difference. I know that this is the 0 term. Okay, but if you don't remember that, you could still find the first 4 terms of the sequence, because if you plug in a 1 for n, I should get the first term. If I plug in a 2 for n, I should get the second term, and so on. So let me do the plug-in method for a moment. If I plug in the first term, if I plug in a 1 for the first term, I get 2 minus 3. I get that my first term, I'm just going to come over here, is a negative 1. When I plug in a 2, I get that my second term is 1. If I plug in a 3, I get that my third term is 3. I want you to take a look at this. It is adding on 2 each time. So the next one should be a 5. I said that this was a 0 term. If I back this up by 2, don't I get a -3? Like, it's all matching everything we talked about. So the first 4 terms are the -1, 1, 3, and 5. And you can find them by plugging in a 1 for the first term, a 2 for the second term, a 3 for the third term, and so on. Or if you understand the equation, that the coefficient of n is your common difference. This added on at the end is your 0 term. When I say find the 100th term, I am going to plug in a 100. So I get 197 for the 100th term. This one I want you to be careful of, read it properly. They want me to find n when f of n is 57. So they're telling me that something is 57, and I have to find what that n is. So it's an equation to solve. Oops, I forgot to add the 3 on. This is a 60. So n equals 30. So be really careful of the given information so that you're not answering the question incorrectly. And then some polynomial practice. Remember, when you divide a polynomial by a monomial, I taught you to rewrite it this way, because the denominator divides into each part of the numerator. X squared divided by x, you know that I like to do it by simplifying. This goes in once, this goes in, and I'm left with x. This goes in once, this goes in once. So the answer is x plus 2. When you're subtracting with polynomials, be careful of that minus sign. Combine like terms, I get x squared plus 7. A binomial being squared means to do x minus y times x minus y. You can do distributing, or you can do the box method, whichever you prefer. The final answer turns out to be x squared minus 2xy plus y squared. And solve for x. When you're solving for x, you need to get the x's to one side. I notice that there's x's on both sides, so I will add bx to both sides. Unfortunately, I can't really add these because they're not like terms, but at least I have the x's on the same side. And this is something that you guys forget. When the x's, when you're trying to solve for x and you got them to one side, but they're caught in 2 terms that you can't combine, this is when you undistribute. And this says x times the parentheses, so I will divide by the parentheses. So x equals 10 over a plus b. And there's more. Next page. A wallet contains the same number of pennies, nickels, and dimes. Same number. That means if I let x equal number of pennies, then I guess I'm going to let x equal the number of nickels, because it's the same amount. And I guess I'm going to let x equal the number of dimes, because it's the same amount. It says that the coins total $1.44. That's money. In order to get money on the right side of my equation, I need something about money on the left side of my equation. These are not money. These are number of pennies and number of nickels and number of dimes. I need to find the value of my coins. So a penny is 1 cent. So 0.01 times my let statement. A nickel is 5 cents. 0.05 times the let statement. And a dime is 10 cents. 0.10 times the let statement. I can use those numbers in my equation because now I have money plus money plus money equals money. Combine like terms. I get x is 9. How many of each type of coin does a wallet have? 9 pennies, 9 nickels, and 9 dimes. And instead of trusting yourself, add this up. Does it add up to $1.44? It does. This is a system on one day for gardeners and for helpers earn $360. On another day working the same number of hours at the same rate of pay, 5 gardeners and 6 helpers earn $4.80. So I just let G equal how much a gardener earns, and H was how much a helper earns. What they earn is money, so really the equation fits like what I had told you with the dimes and nickels and stuff. This is money, and this is money, and this is money, so it all makes sense. But remember, to solve a system, we can do substitution or elimination, and this one is set up for elimination because the G's are lined up, the H's are lined up, the equal signs are lined up, the totals are lined up. I just don't have opposites. So we learned that you can multiply your equations. I feel like eliminating my G. So if I multiply the top by 5 and the bottom by -4, my G's will get eliminated because now I have 20G plus 20H equals 1800, and -20G minus 24H equals -1920. And since these are opposites, they go to 0. Here I have -4H equals -120, and I divide both sides by a -4, so H equals 30, which means a helper earns $30. And then I substitute that number in to one of the equations to find out what a gardener earns. I'll use the top equation. And I got 60, which means a gardener earns $60. And now, finally, graphing. You guys have to remember that if it looks linear, we like to get it in y equals mx plus b form. So I'll subtract x from both sides. Negative y is greater than negative x plus 5. I don't want a negative y, so I will divide by the coefficient of a -1. But with inequalities, as soon as you divide by a negative, turn your sign around. Negative 1 over negative 1 is a positive 1x, and positive 5 over negative 1 is a negative 5. My slope is 1 over 1. My y-intercept is negative 5. So I'll start at negative 5 and go up 1 over 1. Now this is an inequality. So sometimes we have a solid line, sometimes we have a dashed line. Since it's not equal to, and it's just less than, this happens to be a dashed line. And when I got it into y equals mx plus b, since y is less than, I shade down. We have to label the line. I like labeling it the original. This other equation is actually a vertical line. It crosses the x-axis at negative 1. It's solid instead of dashed because it does equal that negative 1. And x less than negative 1, the less thans are this way, right? Negative 2, negative 3, negative 4, that's all less than negative 1. The solution set kind of like goes off the graph, actually. The solution to the system is in here. Remember, it's in a double shaded region. Remember, a solution is never on a dashed line. It could be on a solid line, though. So they're not asking me any other questions, but probably there would be questions on your test, like, is the point negative 1, negative 6 a solution to the system? And the answer is no, because it's on a dashed line. Is negative 2, negative 8 a solution? Yes, because it's in a double shaded region. So I hope this was helpful. Oh, it took me a long time, sorry. And have a great weekend, and good luck on the test on Monday, and there's extra help if you need it. Okay, see you, bye.